A small sphere of radius 2 cm and density 6000 kilograms per meter cube is connected to a cube of mass 200 grams by a string through a smooth pulley. The coefficient of friction between the surface and the cube is 0.4. The density of water 1000 kilograms per meter cube. When the sphere moves with the terminal velocity, find the viscous friction exerted by the liquid. The required equations to do this question as follows. So it is moving with the terminal velocity v. So the viscous force Fv is equal to 6 pi eta Av. Here is the radius of it. And then again upthrust, of course, acted upon it. U equals V rho G, and the volume of a sphere 4 by 3 pi r cube. Right. Now in these equations, let's get into the question now. Right. Now they are telling it is moving with a constant velocity. Terminal velocity, that means it's a constant velocity. So if the system is moving with a constant velocity, so we know there's no acceleration, right? If there's no acceleration, that means there's a frictional force this way because it is moving in this direction, and there's a tension here. So this tension has to be equal to the frictional force, then only it will move with a constant velocity. So we can assume a frictional force is equal to tension now, right? Frictional force is equal to mu r equals tension. So here mu they have given as 0.4, and reactional force mg is 0.2 kilogram. That into 10 equals T. So here we are getting 0.8 Newton as tension, right? So let's consider the equilibrium now. If there's no acceleration, then the downward force mg, if we consider the equilibrium of this sphere, mg should be equal to upthrust, and of course we have viscous force Fe and the tension here T, right? So here we have U plus Fe plus tension, that is equal to mg, right? So we need to find mg, upthrust, and tension. We have found tension, so then we can find Fe here, right? Moving into finding mg. Mg equals V rho G, that means volume into density into simple G. So volume 4 by 3 pi r cube, here pi we have taken as 3. So when we apply in the values density, we are getting the weight of the sphere is 1.92 newtons. Moving into upthrust, U equals V rho G, again volume same 4 by 3 pi r cube. The density is density of water, and then we are getting 0.32 Newton as upthrust, right? So let's get into the calculations now. So here we can take now mg equals tension plus upthrust plus Fe. So we have found 1.92 weight, tension 0.8, upthrust 0.32 plus Fe. So here 1.92 equals 1.12 plus Fe. So we get Fe equals 1.92 minus 1.12, 0.8 Newton. So they are asking us to find the viscous friction, and then viscous frictional force is 0.8 Newton. So we get the answer, second one here. Alright students, if you understood the method, try similar type of questions, and if you think this is valuable, share it with your friends, study together and win together.